Hi and welcome to the 7th episode of China Tools. My name is Dennis and I am from Hooked on Wood. In this episode I want to show you perhaps very simple but also very essential products. It all starts with these kind of products. So today we discuss two engineering squares, one Midas square, and I will hold it against the anchor square I have, and a very nice straight square. But first I want to show you a message about my new site. Welcome on my new website. I made this mainly because of my China Tools series. Here you can find every video but also a ranking among these products I tested, direct links to the products, and if I have plans of projects available, you can download them here directly. So visit www.hookedonwood.online. I want to start with these engineer squares, and it's the metalworkers equivalent of a tri-square, and for us it's ideal to set up your equipment like your bandsaw or your table saw or Midas station or your router table. And of course you can check other squares if they're actually square, or you can use it as a tri-square, although I think the tri-squares as we know it are better for that purpose. So a good square should be exactly square, and everything less than that square makes it useless. There's no in between when it comes to squares. So let's start with this little one. It costs only around $5, and that is a very attractive price for a precision instrument. There are some different designed squares, and this has the shape of a tri-square. And I wouldn't say I like this design to set up the blades of your table saw, for example. If you set up the table saw blade, your square should be exactly at 90 degrees on your blade. And that is with this kind of square more difficult. If you look at the square with a base, you only have to push the square against your blade gently and it centers itself. Usually a small notch is presented at the inside corner of the square. This prevents small particles from accumulating at the juncture and affecting the square reading. But here they have milled the whole last part, and that makes it a little bit unstable when you use it as a tri-square. But most important thing is that it should be square. So how can we check if it is square? The easiest way to check for yourself is to draw a line on a flat piece of wood. Flip the square over and draw another line. But be aware that the piece of timber you hold it against has to be perfectly flat. So take some extra care when you saw a piece for this purpose. By flipping the square you multiply the deviation if it's not exactly square, so it makes it better visible. And it's best to draw these lines close to each other and look if the distance between those two lines are the same. If you want to go one step further, you can do it with a knife, because this makes the line thinner. Another way to check is to hold it against another square that you know is perfectly square and is your reference. And if you do it this way, you have to be sure you put it on a flat surface. With a light source, it's easy to see if there's a gap. And in this case, there's a pretty big gap for a tool that should be that square. With a feel gauge, I measured more than 1/10 of a millimeter deviation. So in this case, one or both of them are out of square. So let's look at the other one for a moment. This square with a base cost around $15, and that is more than the $5 from this square. But if this one is exactly square, it's still a very attractive price. If we look at this square, you see a number on it, DIN 8750, and DIN stands for Deutsches Institut für Normung, which means German Institute of Standardization. DIN develops norms and standards as a service to the industry, and a norm that is used within Europe. And for squares there is a DIN norm, the DIN 875. It comes in 4 different categories, OO, O1 and 2. And each category stands for a max amount of tolerance that is accepted in this category. OO and O are lab quality instruments or used for checking the accuracy of other tools. And the most that we need in our shop is probably category 1 and 2. But this square is in category O. And that means that it has a tolerance of 7 thousandths of a millimeter over its length. And to get that kind of accuracy for this price is very impressive. So if you can test it yourself, this DIN norm is pretty handy because it makes transparent what you actually buy. But let's be fair, although I hope everyone respects these norms, it's also only a stamp, and it's not that I got a certificate with it. But I wanted to get one step further. So I asked a local family company that makes high-end, unique tools and has some state-of-the-art CNC machines if they could help me with the question if these squares were actually square. And because accuracy is essential in their business, they have the machinery to find it out. First, we started with this small and very affordable square, which has no DIN norm. And while we set up the machine, look how smooth this machine worked when we were turning the wheel in the back. I found this smoothness very impressive for such a big device. As you can see, and what we also saw when we hold it against the other square, it is not good. The deviation on this length are more than 1/10 of a millimeter and probably 1.5 tenths of a millimeter over its whole range. The other square was made according to the DIN 8750 norm, and although we cannot measure thousandths of a millimeter this way, at least we should not see any movement on this meter. And as you can see, this is spot on. So we have a very accurate engineer square for very little money, and that is even accurate enough to check other squares. So let's summarize what we just saw. This $5 model had around 1.5–2 tenths of a millimeter deviation. And that amount of deviation is clearly visible. So if we set up our table saw blade with this square, we put it out of line. And that makes this square useless. And although $5 isn't that much, by buying it I threw them away. So I hope you can save them. And this is my scoring card. If we look at the $15 square that is built according to the DIN 8750 standard, it's a real bargain. And we do not need this kind of accuracy. We can't transport measurements from 1/1000th of even 1/100th of a millimeter. But of course, it's also not a bad thing either, to get a square as accurate as possible. And with this square, you get a very accurate reference for a very low price. And this is my scoring card. Next is this Midas square, and they are pretty hard to find. I already had one, this Incra, and I paid $90 for it. And that was mainly because I did not saw any alternative at that time. So when I came across this angle square, I wanted to give it a try because it can save you a lot of money if you need one. This one is made according to the DIN 8752, which is the same accuracy that Incra claims, and this one costs only $22. I like to use bevel cuts in my work, and I want to make them as perfect as possible. Here I made a box for a doweling jig Banggood sent me, and you almost can't see the bevel cut at the corners. And I found that very satisfying. So if it takes a little bit more effort when setting up your saw blade for these results, it is worth it for me. And for this you need a right angle square. I have a lot of Incra stuff in my workshop, and I really like Incra, but this square never satisfied me. So even after a short time of use, I'm glad that I have this one already. Because of this base, it's much easier to put it straight against your blade for a more accurate setup. If you put the Incra on its base, we cannot set up the saw blade. So we have to turn it around, but I do not like this because it makes it unstable. And it's hard to see if it's straight against your saw blade because you're missing a piece. The advantage of the Incra is that you can also use it to set up your table saw at 90 degrees. Both have the same tolerance, as DIN 8752 is about the same as the 1/1000th of an inch accuracy of the Incra. And although the Incra has a base, it's not perfectly leveled with the middle piece, and therefore it's always a bit unstable on its feet. What I never understood from its design is that if you want to use it to draw a line, I can't draw it entirely to the edge. Of course I can use it from the inside, but that's not ideal, and with a bigger pencil you cannot reach the corner inside. So drawing a line with this square makes it much easier. And finally, there is the material used. Incra made this of hardened aluminium, and this one is made of steel. Incra claims that if it drops, it won't easily change the angle, and I believe so, but I found the material pretty soft, and I dropped it once and you get dents. And if you get dents, you also get somewhere else lumps. And although the angle is not changed, it is not flat anymore, and because of that, not accurate. So I had to sand the unevenness away gently. This square is much denser, and although I think you should never drop a square, if it has to fall, then I rather prefer this one to fall for two reasons. One, because it's denser, and second, it's much cheaper if you have to replace it. And this is my scoring card. Last product is this straight edge. It's made of stainless steel. It has a bevel on it, which makes it easier to see if something is flat, and it has an insulated grip, and this is because the heat of our hands can expand the material. We are talking about that kind of tolerances. So again, overbuilt for our use, but for this price of only $20, I like to have this kind of high-end references. It is built according to the DIN 87400 norm, and that means that according to this norm the tolerance in its flatness is 0.004 of a millimeter. And our friends at a tool company have, of course, a flat granite table. That is a reference. And I immediately felt when I put this one on that table that it is very stable and flat. And with the light check you see no leaks. And although I can't check differences of thousands of a millimeter, I think based on what I could check, this is also a lovely product and does what it claims to do. I like this product because if you want to check your table saw blade, you have to check your insert also. Because when your insert is not straight and in line with your table saw, you set up the wrong angle. A few weeks ago I made this video about this zero clearance insert. And Marisa asked in the comments why I put these holes completely through the insert. Well, that is because I use Torx cap screws, and now I can tie them from above, and that makes it much easier to level them. And we're all humans, and when it becomes harder to do something, we cut corners. So I think it's important, and I want to have minimum excuses for myself to set up my insert regularly. And of course you can use it to level and check a lot of other things in your shop, like your table saw insert, your router table, your miter station, or the flatness of your planes. So a very high-end product that comes in different sizes, and I found it very useful. And for around $20 I think it's a very attractive price, and this is my scoring card. In the last episode I discussed this height gauge, and I was very enthusiastic about it. I even gave it the highest score with the exclusive first class product stamp. But I got a comment from Hondo who commented that he was not impressed. And he was right in some ways. And although his remarks were not all about this height gauge, I feel I could do better. I do these reviews the best I can, and I don't want to give information that is not correct or say that something is good when it's not. And I'm not an expert in every field, not at all, but I take my responsibility to let me inform as good as I can before I say something in these reviews. So when I was at the tool company, I asked if I could check this height gauge. And keep in mind that this is a height gauge of only $40. We start with a sample of 20 mm, and as you can see on an industrial machine, it measures 0.005 of a millimeter deviation. When we check it with our $40 height gauge, it is very close with less than 100 of a millimeter deviation. So that is pretty accurate. The 50mm sample was spot on. And with our height gauge, there was again 100 of a millimeter deviation. The 100mm plate measured 100 of a millimeter deviation, and our height gauge measured exactly the same. Later I played a little bit around, and I measured also a 40mm plate and a 70mm plate, and they were perfect. I think they did what they reasonably can do within this budget to create an accurate height gauge. And in my opinion, they delivered it with this machine. So I'm even more impressed after this testing. That does not mean that there are probably better machines available, as are even better constructed on the internet. But they cost around 5 to 10 times more. The most significant deviation we measured was only 1/100th of a millimeter, and that is really small. And that is also what Hondo claims on his comment. We cannot transport this kind of accuracy, and he is right about that. If I measure the thickness of this timber, only a little bit more pressure gives more than tenths of a millimeter differences. So how can we possibly transport values of hundredths of a millimeter? But that said, it is a starting point, and in my opinion that should be as good as possible. And I like what we get from this height gauge. It is massive, made of good materials, and very accurate for an excellent price. So anyway, I'm glad that I had the opportunity to measure it this way. I'm glad that Hondo came with his comments and triggered me to go one step further with it. And I'm even more glad that what I said in the last episode still stands. In the previous episode I told you about the giveaway promotion. And I like the comments so far, and I want to encourage you to continue giving me your suggestions of the top 3 woodworking products from Banggood you'd like me to review. My goal is to review the most common suggestions. So visit Banggood with one of the links in my subscription below and look which product you like me to review. But I asked Banggood if they could change this product for something else, and they did. So I can give away 2 of these hinge jigs, but also both of these T-rulers, and this one I really like. And I hope that will make this giveaway action even more attractive. So keep your suggestion coming, and I will choose at the end of this month who will get these nice products. Oh, and of course, no matter where you live, everyone can join this promotion. And I'm very sorry that I forgot to mention my best friends from Belgium in the last episode. So I hope, Wim, you will forgive me now. Well, it was a long one. I hope you find it interesting. Have a nice day, and I will see you next time.